So there's a little secret time symbol in there. Here, I'll zoom in a little bit. In fact, I'm just gonna write it in. So A, which is area, is equal to length times width. So length and width, these are the only two numbers I have. I just take my two sides and multiply them together, and that's going to give me the full area of it all. Let me make this red, make this bigger. So I just put in my formula, length times width. It doesn't matter which one I actually choose as my length and width with rectangles. You can do either or. I'm just going to take the two numbers, I'm going to times them together. So I have 6.8 centimeters times 4.5 centimeters. And then all you do is you just go to your calculator and you just multiply those numbers together. 6.8 times 4.5. You're going to get 27. And specifically 27 centimeters. I got 30. Oh, did I goof up? Oh, yeah, I did goof up. Sorry, 6.8. Oh, yeah, I literally have to 6.8 times 4.5. I forgot to press the 8. Nope. Yeah, sorry. So 30.6. That's my bad. And so this is where it's actually really important to keep to have an understanding of what we're doing when we have like these centimeters. So like when I'm times in 2 centimeters together, which is why I'm getting that little 2 there, which is why I'm getting that squared there. So this is saying that the area of all of this is 30.6 centimeters squared. So just like the tile, 45 centimeters times 45 centimeters, it has an area of 2,000 squared centimeters. This is just like that, just a lot smaller. So rectangles are pretty easy. You literally just take the two numbers and times them together. It's when we get to triangles that it's a little weird. And so I'll show you what the formula is for this right now, and then I'll explain what the heck that actually means. It'll make a lot more sense. So A equals a half times BH, base and height. So I'm just going to quickly write that in here. Oh, we can actually go underneath. I'm going to go underneath it. That's what I should have done. So A equals, I'm going to write that half times B times H. Remember, we're lazy. We don't write those X's in our formula, but so let's make some sense of this. This base and height. That's kind of just like what a rectangle is, isn't it? Well, I take the base of it, I times it by how tall it is. Oh, that's length and width, base and height. It's the same thing technically. So where do we get this half from? So don't draw this in, but it'll make a little bit more sense once I do this. Or actually, no, I'll just do this instead. A triangle is just simply half of a rectangle, which is why we cut it in half. Now, even though that this is still some weird, like this isn't a right angle triangle like this, but a triangle is just half of a rectangle. So it's the same formula. We just cut the answer in half, and you're going to get it. Even with this thing here, again, don't draw this, but if you were to take the areas of these red things here and add them up, it would be the exact same as the triangle that's in that. So it's a universal rule basically with triangles, is that it's always going to be half of the size of the rectangle that's in. So all I need to now do is just plug this stuff in. So I have my formula, and now I'm just going to substitute my stuff in. So my base is, well, it's 12.8 centimeters. And my height. Now this is important. The height is the thing that goes purely up. If I had this one here, if I had this line, that's not the height. It's not the pure height of it. It's the one that goes straight up. That's a really common mistake people make, is you have the number that's actually going purely vertical. So my height in this case is 7.8 centimeters. It's a half. Then all I'm going to do is I'm just going to take my calculator and just fill those numbers in. And end up getting 49.92. .92 centimeters squared. Come on, computer. So this next shape, anyone know what this one's called? This is a parallelogram, technically, this shape here. And we can see that because we have these little lines, these little like black lines here. That just shows that these lines could go on forever and ever and ever and ever, and they'll never touch. That's why they both have that. No, go away, whatever that is. So now this one here, parallelogram, is a little weird. The formula for a parallelogram is the same thing. It's base times height, length times width. It's the same as a rectangle. It's the exact same still. But how does that make sense? Well, this little red part here, that's just this part taken off, chopped off, and moved. So these are the exact same. This is why it's the exact same area as a rectangle. So all they did is they took this, chopped it off, and moved it over here, but it's still technically a rectangle. We've just moved some of the parts of it, but it's still the same area. So we still solve this the same way. My area, A, I'll zoom in, is equal to, it's the base and the height. It's the length and the width. You can do either one of them, that's fine. So I identify the shape, find the formula, substitute the numbers in. My base is 3.1 meters. Now my height, and just like the triangle, I care about the line that goes straight up. I do not care about what I'm highlighted in red right now. This is not the height. What I'm highlighted in red is not the height. It needs to go straight up, purely vertically up. Which is why 2.1, this little line going down, that is the height. That, again, really common mistake to make. So 2.1 meters. And all I do is I just plug that in. It's going to give me an answer of 6.51 meters squared.
So then the trapezoid is exactly the same thing as this, except it just doesn't have those arrows.
This one, you're right. So yeah, these just have non-parallel sides, which we don't care about right now. It'll make sense later, but yeah, it's the exact same way. We'll end up looking at this. This one's a little weird. It has a really weird formula for it, but we'll end up dealing with that one later. Now, the one that tends to freak out a lot of people out is the almighty circle. The reason we kind of get a little scared of that one is because we're seeing this new figure here. This is pi. I will explain more about like what pi is later. Like it'll make more sense like what that number is. But if you go in your calculator and if you find the button for that, which should be near this top right here. It should be beside the DMS button. If you just press that, you press enter, and you change it, you're going to get this number here. So first off, you're not going to have to memorize this number. You're going to see it so many times, like eventually like 3.14 tends to be like the accepted. I'm just going to substitute this in, but your calculator knows what pi is. It's a number that goes on literally forever. It has trillions of digits. It's just programmed into your calculator. So the formula here is A equals pi r squared. There's a couple things there, but you can see r here is this line. R in this case is going to be my radius. And your radius is just the measure of the line from the center of the circle and just a straight line to the side. That's what that is. So this is our radius here, and it's just looking at the middle of the circle to the edge. So let's solve this one here. So I already said that, so it's A equals, so pi. It's a weird symbol to draw. You'll get used to it eventually. Technically, I'm not doing it right here. A lot of people do it shorthand like this. It's like, this is a bad habit I picked up when I was in school. But if you look in your calculator, there's a more like official way of doing it. It comes from a Greek alphabet, which is why it looks a little weird. You can do anything. I've seen a couple variations as long as I know it's pi. So it's pi times r squared, which is the same thing as, oh my gosh, type it in. Which is the same thing as A equals, so area is pi times radius times radius. This means the exact same thing. So you can input this either way into your calculator. That's fine. I'm just going to substitute it in. So I don't know what my area is, but I know my radius. I know what pi is. My calculator has that. And I know my radius is 4.5. So it's going to be 4.5. centimeters. Now, I recommend put your stuff in brackets, because otherwise you're getting 4.5 centimeters like squared just like that. It is not a unit of measurement technically. I'm actually squaring that number itself. And at the end, what I should get calculator. There we go. And so in your calculator, it would look like this. Literally, so area equals pi times radius squared. So pi times my radius is 4.5. I'm going to press that little squared button. That's that X with a little 2 near the middle of your calculator. So literally exactly, so it should display exactly like what it's supposed to do. Pi times the radius squared. You punch that in, change it to that symbol. It's going to be 63 point, we'll just say 6. So 63.6 centimeters squared. So easy enough until we start throwing curveballs. Curveball, right? But the world is not nice, easy shapes. The world has some complications with stuff, but we can use those basic principles of, remember, 3 shapes. Everything you need is just those 3 shapes: triangle, circle, and rectangle. You can divide up pretty much everything into that. If you look at video games right now, like, I mean, if you look at video games really back in the day, like you ever see the ones in the 90s, you like, it's all made up of triangles and squares and stuff. You see that. Today, you know, graphics are really good in video games, but it's still made up of triangles. There's just millions of them versus like, has anyone ever seen like that original like Tomb Raider video game photo? Like it looks like the Tesla Cybertruck. There's like 30 triangles or something. So now for this shape, how can I find the area of this shape here? Any guesses?
Would be the 12.6.
Oh, so like use this 12.6. It's involved with it, but I don't have an area. I don't have a formula to find the area of a shape like this. There's only 3 shapes I really know how to find. So what I need to do is I need to turn this into those 3 shapes. All of a sudden, oh, well, that's just the rectangle, rectangle, and triangle. This becomes a lot easier now. All I need to do is break my shape up into more manageable things. So you could do it this way. You could do something like this too if you wanted. I'm going to keep it easy. I'm just going to do 3 lines for now. So just like with graphs, sometimes your graphs are a little bit different. Sometimes you're going to have a different solve for these types of things. This is called a compound figure, by the way. Actually, I'm going to write that in. So this is called a composite figure or shape. And what this means is we have a complex shape. We need to break it down into simpler ones. We know how to find the area of a triangle and a rectangle. That's really easy to do. So we turned it into triangles and rectangles. So the hardest part you are going to have with this is keeping it organized. If you keep this stuff organized, it will be so much easier. So I'm going to quickly label my shapes. Shape A, shape B, and shape C. Or sometimes you might just write the final answer of, okay, well, if I find the area of this square, I'll be good to go. And you might write it in there. So when I have a composite figure and shape, there's a set of steps I need to follow. And step 1 is what we just did. Turn into simple shapes. So my step 1 is I'm just going to turn my composite object into simple shapes. I have done that. My second step is label each shape. I've done that already now too. So I've already done most of the work. The third step is we need to find the lengths of all, we'll say sides, sure. And I'll explain what that means here in a second. So if I want to find the lengths of all the sides, what does that mean? Well, if I zoom in here a little bit, I'm just going to go to my shape. If I want to find figure A, so we have length times width, right? I have one of those, but I don't know this measurement. I need to figure that out using the information I have up on there. It doesn't directly tell me. So when I say find the sides of all, or find the lengths of all sides, it's finding that missing information here. So here's what I know. So I'm gonna use a highlighter for this, make it easier. I know the length of this line here, right? It's 13.4. I know the length of this line here. It's 6.2. Can't I just take 13.2 and take away this little part here? And then I'm just left with only that? No, I can do that, absolutely. The whole line's 13.4. I know this part of the line is 6.2, so I can just take those away to figure it out. So I'm going to quickly do that. I'm literally going to take not 16, 13, 13.4, and I'm going to take away 6.2. And if I do that, I can see that the length of this line now is 7.2 centimeters. So use what you know to find what you don't know. Is there any other shapes? So if we're looking at A, B, and C, is there any other lines that I need to figure out?
12.6.
The 12 point. Oh, so that's the height of this triangle here. But is there any other shapes that I need to look at? Like, can I now find the area of A? Yes, because I now have the two sides I need. Can I find the area of B? Well, with the area of B, it's a rectangle, right? So what do I need? I need the length and the width. Well, up here, actually, I'll use my highlighter. I have that. Do I have the height of it? Do I have one of these two lines here? No. But what I do have is I'm going to use red or pink for this. I do have the length of this line. It's 3.1. I do have the length of this line. It's 6.8. So what can I do with that information now? Just add them up. 6.8 plus 3.1. The whole measure of this line in pink. Can I even do that? Yeah, I'm just going to do that. The whole measure, so 3.1 plus 6.8 is going to be 9.9 centimeters. So boom, I'm good for shape B now. I have the two things I need. And then for a triangle, what do I need to find the area of a triangle? Base and height. Do I have the base? This is kind of a trick question. Which one of the numbers is the base? So it would actually be 9.9. Because height is the one that measures it from the tip of the triangle all the way to the base of it. So this number, even though it's on the bottom, this is still technically the height of this triangle. But I have that. I have the height of the triangle, and I have the base of this triangle. These two lines here and B, those are the same. So I've done it. I've now officially labeled I've found the lengths of all the sides. So now I can go on to my next step, which isn't too hard. We just showed we know how to do it. Find the area of each shape. So I'm going to keep it nice and organized. Now, you do not need to write out all these steps we're going to do in the future. What a lot of people do is they will literally just figure out, okay, shape A is, it's 20 or something like that. I don't know what it actually is, but that's how they keep themselves organized. People have done that, and that's totally okay. For the use of an example, I'm going to show you like a longer way of doing it. But eventually, you guys will probably be able to just be like, you'll be able to do this really quick with nowhere near this amount of work, and that's fine. But basically, shape A. What shape is that? It kind of looks like a square. It's not because the sides are different, but it looks like it. But it's a rectangle. Technically, squares and rectangles have the same formula anyways. So, sorry, I didn't mean to write rectangle. It's a rectangle, and the area of a rectangle is length times width. My length of this is, I'm just going to say it's like 6.8. You're just taking the two numbers, times them together. And the width was 7.2. So then all I need to do is times those two numbers together, 6.8 times 7.2. You should get 48.96 centimeters squared. So again, some people, they just skip all of this. Like, because you can kind of do this straight on your calculator. Oh, I know it's a rectangle, and I know it's these two numbers times. So they'll just go straight to the answer, and that's okay. You just want to make sure you have it written down somewhere. So I've said, hey, shape A is this. What you could also do is you could just write it in here. Hey, it's 48.96. 0.96. You could do that too. That works. So it's whatever you prefer. But as long as you're keeping track of it, you're okay. So I'm done shape A. Now what I need to do is I need to go to shape B. So shape B is also a rectangle. So it's the exact same formula. Length times width. I'm going to say my length is my 9.9 centimeters. You could do it the other way. It's not going to matter in this case. 9.9 centimeters times 6.2 centimeters. And if you do that, you should get a final total area of 61.38 centimeters squared. So I'm 2/3 done already. So now all I need to do is I just need to do my third shape. Which is the triangle, yeah. So formula for a triangle, yeah, a half times base times height. We use shorthand because we're lazy. It would suck to have to write length and width and base and height all the time. The fraction here is really important. You could substitute 0.5 if you want, but it's really easy to make a mistake on your calculator. You know, you're tired, you're not thinking, you're just powering through the questions, and you might accidentally do, well, here, I'll show you that in a second, but cool. So all I'm going to now do is just same thing, substitute it in. I still have a half. My base is going to be 9.9. My height of this was 12.6. And then all I got to do is just punch those in my calculator. And so this is where it's really common. A really common mistake people make is they'll do this. Really easy to do. This is not the right way to do it. That you just forgot to use your little arrow key to move it past the decimal or to move it past the fraction. So just make sure you're using that arrow key to get it so that it's not going on the bottom of that fraction, not going on the denominator. 9.9 times 12.6. So if I do that, I should get a final answer of 62.37. Squared. Now my question for you is, am I done? No, because it wants to know the area of all of it. So how do I figure out the area of all of this?
Would you add up all the areas? So 48.96 plus 61.38, 62.37.
Yep, I know what figure A, figure B, and figure C's areas are. Just add them all up and you're good to go. So all I'm going to do is I'm going to add, I'm going to put slash subtract because sometimes you're going to have to subtract actually to figure it out. The area of each shape. So really simply put, it is literally shape A plus shape B plus shape C. That's all it is. So 48.96 centimeters. And again, this is a really long way of doing this. You don't need to go to this level of detail. That's okay. You might just punch it in your calculator and be like, shape C is 62.37. So you might just be shape A is this, shape B is this, shape C is this. No work, that's okay. And then you just might be shape A plus B plus C equals boom, final answer. That's okay. I'm writing out all the steps because it's an example. This is one of those places where you definitely can shorthand it a little bit. Here, I'll zoom in a little bit. So my final answer is going to be 172 of all of these shapes added up, 172 and 71. Now for my centimeters, here's a question for you. Is it going to be a 2 or a 6? It's still a 2. It's still squared. I'm still measuring area. Area is always squared. And I'm going to circle my final answer. This is going to be a good habit to get into now because we're getting into more complicated work. It has more steps involved. It's not a bad idea. Circle the final answer. The organization here is pretty important. Like I always recommend, like, just properly label stuff because otherwise what's going to happen is sometimes you're going to be working on a problem for 10 minutes. You're not going to remember what was what if you just say 48 and then 62 and then like 73 over here. Like it's not going to click as well. So if I would just say shape A or A equals 48.96, and that's okay. Ooh, right there in the eyes. Okay, so those are 2D objects. But we're also going to be looking at 3D objects as well. So we're looking at 2D and 3D. Now, I'm just going to give you the names of these things here. So we have A, B, C, and D. We have different shapes. But these are the actual prisms. These are all going to be prisms because they are 3D objects. And so what we do is, so I know it's going to be a prism. All I need to now do is look at, we call this, what I'm highlighted in red right now, we call this the face. It's what we're looking at in it. And then it's just 3D after that. So we use that to figure out the name of it. So first off, what did I circle in red? What shape is that? It's a rectangle. Absolutely. So figure A is going to be a rectangular prism. The face is a rectangle. It's a rectangular prism. Does anyone know what figure B is? Oops. It is a hexagonal prism. You are correct. Because it has a hexagon as the face. It is not a rectangle, even though but it's a rectangle on the front of it. Well, no, but we don't really care about the front of it. We care about the face of it. The side of it is a rectangle, absolutely. But the face of it is a hexagon. I am not going to ask you to memorize this, by the way. So you're not going to need to make flashcards and crap, is it a hexagon or an octagon? That's okay. I just want you to be able to identify that, oh, it's a 6-sided shape. That is all you need from this. You don't need to you probably will have it memorized just through working with it, but that's okay. So C is pretty easy. What shape is that? Triangle. So it is going to be a triangular prism. And then any guesses for D? That's a weird one. So this shape here is a parallelogram. Now, do you know how you're not going to write, oh, it's a parallelogram prism. This one has a fancy name. And again, this is one of the reasons why I will not have you guys remember it? This is a parallelepiped. If you said a parallelogram prism, you're fine. Oh, this is a D. It's a parallelogram prism. It just has a really fancy name. I don't know who named it. I think it's a dumb name personally, but All right. Now, this next question here is going to be, so first off, we can identify what this shape is. This is a pentagonal, pent means 5, it's a 5-sided face here. A pentagonal prism is made from cardboard. What would each piece of the cardboard look like? Yeah. Oh, I guess it kind of counts. That box, but have you guys ever had a flat in the box before? Like a whatever, maybe a burner or whatever, right? Like a net is just going to be what that cardboard is without the tape and stuff. It's just a nice flat paper. We see this all the time in, come on, move, gingerbread houses. When you get a gingerbread house kit, you just get the walls and like the roof and stuff like that, and you have to build it from there. So it is a net. Second. So normally when you get a box and if you flatten that out, this is kind of what it actually looks like, right? Like if I take that Christmas tree box up there, and if I were to flatten that out, that's what it would look like. I'm not going to do that because I need that for storage, but that's what it would look like. So this is what's called a net, which is basically like it's the blueprints of it. As a nice flat object, before I start folding it in, stapling it, and taping it and gluing it together, that's what it's going to look like. So it wants us to do here, and this is a tricky skill, just like graphs, where you're not just going to be an instant graph expert. Nets are a little bit of a tricky skill to get, but what it wants me to do is it wants me to know is what would the piece of cardboard look like? What would the net look like? That's what it wants you to draw the net. That's what it's asking us to do here. So let's actually do that here. So first off, how many sides is this shape going to have? 5, yeah. There's 1, 2, 3, 4, and 5. So I know there's going to be 5 sides to it. And now this shape here, what is that? It's a rectangle. You might be thinking, well, it's a parallelogram. It's just kind of like drawn that way to show you it's 3D. But so that is going to be a rectangle. So what I always recommend is when we're drawing a net, start with the bottom or the base of it, right? What does it rest on? So I want to draw this net. So specifically, I want to do the bottom of this shape. What do you think the bottom of this shape is going to be? What shape is that? It's going to be a rectangle, right? Like technically, this is what that shape is. It's just a little rectangle. So all I'm going to do is I'm going to draw a rectangle here. Put it in the middle. You need to give yourself some space here. All I'm going to do is I'm just going to draw a rectangle. And that's it. Now, this base, though, has something attached to it. It has the face attached. It's kind of like, have you ever seen like those movies of like a barn's wall falls down, like there's a guy who goes straight to the window and he's fine? Think about it like that. Like this thing just falls flat down. What would it look like? Well, it's just going to look like the face of it, but it's attached to it technically. We will eventually fold one of these up. But technically, this is what it's going to have. It's going to have that face attached to it too. So this is all still the bottom of it. I'm actually going to label that. You do not need to do this. I am labeling it just to kind of give some context here. So this is the bottom and base, basically. We always start with the bottom of it, always start with the base of the shape that you're drawing a net for. And then all we got to do is we just got to start ticking down sides. So when I go to fold this, I'm starting at the base. What's the next side that's attached to it? Well, it's this thing here, right? Which we already identified is a rectangle. So this is the side. And again, this will make more sense. I'll try and bring a box and we'll actually like rip it apart. But so I have the other side, and then opposite of that, I'm going to have the other side. Because there's technically two sides to this, right? So I've done the bottom and I've done the sides. What's left on this? Yeah, the roof or the top, either's fine. Now, what shape is this one? It's also a rectangle. So I'm gonna say roof, because most people look at this, they think about like a house. And if you're always wondering, well, how do I know? How did I get it right? Like, did I do it right? Like, these tend to be a little bit trickier. Because like our brains don't work with it. Our brains don't do well at deconstructing objects. This is why this type of stuff is an IQ test. How many sides are in that shape? So there's the 5 sides, but there's also the 2 faces, the front one and the back one. So there's actually a total of 7. And how do I know if I got it right? 1, 2, 3, 4, 5, 6, 7. I've gotten it right. It's everyone always says 5, so don't feel bad about that. But this is my net. I've drawn a net of it. If I were to cut this out and I were to fold it up and glue it together, you'd get that shape there. So it's the 2D version of the 3D shape. So what some people like doing is on this next question here is they like drawing nets of this. Personally, I'm not going to do that. You can if you want. That's fine. But what this question's asking me to do is I want to find the surface area of this prism below. Now, my question for you is, how many sides does this thing have? Technically, it's going to have and give you that. So right now, we are all in the Stilts cookies. We are all holding a rectangular prism ring. So just at that same angle, we'll have a front, but there's also going to be a back. I have a top, but there's also going to be a bottom. I have a left side. I guess for you guys, angle left side. I also have a right side. So in like we're all holding a rectangular prism. How many sides are there? 6. 6. Okay. Yeah. So technically, there. Sure. So this is that same thing. There are 6 sides of this, but we can only see 3 of them. But if I know that I have a front, I also need to have a back side, right? If I have a top, I also need to have a bottom. If I have a right side, I need to have a left side. So all I need to kind of do is just figure out the area of each of these 3 sides and then just double it, if that makes sense. So technically, all we need to do here is we just need to add up all 6 of these sides. So what I like doing personally, there are different ways of doing this. I like doing the front and the back. This whole thing is technically the front and the back. It's the top and the bottom. And it's the left side and the right side. If I add all 6 of those sides up, I have the actual area that prism takes up. It's measuring all 6 sides. A really common mistake here people will make is they're going to measure, okay, I have the front, I have the top, and I have the side. I add 3 of those up and I'm done. That's a really common mistake people there make is, well, you only have 3 of the 6 sides. So we're gonna try and actually condense this a little bit. We're not gonna go as intense as we did up here. So let's just quickly power that through. So F plus B, that stands for front and back. So first off, for the front and the back here, what shape is that? It's a rectangle. What two numbers am I going to multiply together?
4.6 and 3.8.
So I take 4.6, which is the base, and then I take the length of it, and then I take the width of it, which is 3.8. It is always going to be a straight line. If you're ever unsure, like when you see over the back line here's measure, you can take your ruler without turning it, don't turn it, keep it straight. You can move it around, it lines up. It's the same number. So it's going to be 3.8. So my front and my back is just going to be, so first off, I'm doing two sides. So I'm going to do 2 times the length and the width. The length was 4.6 centimeters. The width was 3.8 centimeters. Make this bigger. So then all I have to do is just plug that into my calculator. So 2 times 4.6 times 3.8. And I can see it's going to be 34.96. Oh my gosh, come on. 0.96 centimeters squared. So the biggest error you are ever going to make with this, the most common mistake you're going to make with this is you are going to forget that 2. You're going to forget to double the side. Some people like just taking, they don't do the 2. They'll just do the 4.6 times 3.8 and they'll double it later. That's fine. But you have to keep organized. Organization is really important for this. As long as you know that, okay, did I double it yet? Yes or no? You're good to go. So my front and my back, I've now established is 34.96 centimeters squared. So I've done that. Now I'm going to do the top and the bottom. And again, we're mathematicians, we're lazy. Top plus bottom, T plus B. So this top here, I need to take these 2 lines and add them together, right? Just take your ruler. You're trying to find this one, and you just go down and turn it. Eventually, you're going to land in on it. Okay, well, I know that this line is 4.6. This line is 4.6. I have the width of it. Now I just need the length of it. Same thing. If you're ever unsure, you just take it. You can go without moving it. You have to rotate it. You just then it's going to be 1.9. So it's 1.9 times 4.6. What did I say? It was 1.9. So I'm going to go 2 because I need to double it. So 2 times 1.9 centimeters times 4.6 centimeters. It's really easy to make mistakes with this, right? We have lots of numbers. It's multiple steps to solve. Maybe you accidentally times it by 3.8 instead, right? That's why it's important to show your work for this.
By the way, these are meters.
Oh, they are meters. Okay. Whoops. It'll still be the same number answer. 1.6. Thank you for that. I'm just going to do that. And if you do that, you should get 1.9 times 4.6 times 2, 17.48. Sorry, meters squared. I'm doing it again. And so what two sides are left now?
The sides.
Just the sides, yeah. You can just say sides. I like doing left side plus right side, but it's dealer's choice at this point. I'll know what you're talking about. So I'm going to take my sides. Now, what two numbers am I going to multiply there?
3.8.
3.8 and 1.9. You're absolutely correct. So I'm doing two of them. That's why I have this 2. So 2 times 1.9 times 3.8 meters. So if I do that, I should get 14.44, I think. Cool. So again, really common mistake people make here is, well, not mistake, but just a difficult situation is maybe you write really big. You notice how I have my stuff pretty well organized here. Like I've labeled what each thing is. They might forget what number, because again, you're gonna be looking at this for multiple minutes. Your short-term memory just might like blank out on it, right? That's fine. That's happened. That's why I'm keeping myself organized up here at the top, 17.48 meters, and the left side and right side were 14.444 meters. So what do I need to do to finish this off? I just need to add all of these up to get my answer. So if you punch those in your calculator, I've already doubled it, right? We've established that I have doubled it already. I don't need to add these up and double it because I've already done that part. So all I need to do is add these up, and I should get ooh, yeah, 88 meters squared. It is my final answer. I'm going to circle it. So all I did was add these 3 numbers up to get that. Okay. I'm just trying to think here. We got 2 more to go. Why don't we take our break now before we finish off here? So why don't we give you your 15 minutes? We're going to finish up our last 2 questions here. Now, this one here it's exactly the same thing we did. The shape itself, though, is just a little bit difficult. It's the same thing, though. We're finding the surface area of this prism. The only real problem with it is that it's a compound 3D shape. It's a little bit tricky, right? It's taken this question here, this composite figure, and it's taken the question we just did, a 3D figure, and it's combining that. So I will be blunt. This is like the hardest level it's going to get to. It's not going to get more difficult than this. This is a little bit tricky. This is where that organization really comes into handy. What we need to do is we kind of need to figure out the surface area of all of these shapes here. My question for you is, how many sides does this shape have? So we got the front, the back, that's 2. We have the bottom 3, 4, 5, 6, 7, and 8 is what it should be technically. There's a bunch of different ways to solve this. One of the ways is we can literally just figure out what every single one of these sides is and add it up. Another thing we can do is we can just split it up into 2 separate shapes and add that up as well. So we could do that where we either split it up into maybe a shape like that, and then we have shape 1 and shape 2, or we could just add up every single side of it. There's different ways of doing it. You could split it up into a shape like this if you wanted it as well. So it's going to be one of those things where you're always going to get a little bit different ways of doing it now. So just like the graphs, everyone's stuff will be a little bit different. 1 second, sneezing. Oh, excuse me. What I'm gonna do just for the example here is I'm actually gonna split it up into 2 different shapes. I'm gonna call this. I'm just gonna go with shape 1, and then the bottom part is shape 2. So shape 1 and shape 2. So we solve it just like that compound one, just this time with all the different sides. So the first thing I need is, okay, so just like the steps from way up top here, is I've turned it into simple shapes. I've labeled the shapes now. Now I need to find the lengths of all the sides. I still need to do it the same way here. I still need to find the length of all of these sides here. Specifically, for this top shape here, I need to know the lengths of all 3 of these lines. Now, how can I figure out the length of this line right here?
Would be 55.
So the whole line that I'm going to highlight here in yellow, this whole line's 55, right? To figure out the whole line of this whole line is 55. Figure out this line here. What I need to do is I need to take away this part, right? This part needs to go away. So I know how long that part is. No. Okay. 30. So that was 30. So all I have to do is take 55 minus 30. And I'm going to figure out what that is, which is 25. Oops. So this whole thing here is 25 centimeters. I'm gonna make this a little bit thinner. So does that make sense where I'm getting that 25 from? I don't know what that was. So the whole thing's 55. I took away the part I knew, which was this 30, and I'm left with only the 25. So now I'm going to figure out this. I'm going to highlight in yellow again. I'm going to figure out this top line here. So the only thing I have is, remember, I'm looking for lines that are parallel. That means like I can take a ruler, I can not turn my ruler, I can just go up and down, and I know this line here is going to be part of this. So if I want to figure out I want to figure out the length of this red line here. How do I do that? Just tell me in English. What do I do? $78 by 45. Absolutely right. That's perfect. The whole bottom line here is 78. I know this part here of that line is 45, and then I'm just going to be left with what I want. So perfect. So 78 minus 45 will give me 33. That is perfect. And then finally, do I know the width of this shape? Do I know this line? That's just 27. That one's already given to us. And sometimes it will, sometimes we have to figure it out. But this one here is going to be 27 centimeters. Cool. So the top, I have all my figures I need now for the top, right? So I can do that. I'm going to now figure out the bottom. Do I know the length of this line?
That's 30.
That one's still 30. So you could draw that if you want. I'm not going to, but it is 30. I know the width of it. I know the height of it. And I know the length of it as well. So I'm good on the bottom shape now too. So I've done it. I have labeled all my sides. So now all I need to do is, just like before with our other figure, is I need to find the area of each shape. So I've split this one up into a top and a bottom part. Like I said, you could, if you wanted, split it up into something like this as well. It's not the only way of doing it, but so now what I'm going to do is I'm just going to figure out shape one. So shape one, how many sides are in shape one? Only look at that top part. That when I say shape one, it means only that top part. So there's 1, 2, 3. So there's a front and a back. There's a right side and a left side. And there's a top. Is there a bottom? There's not a bottom in this case. It's attached to that shape, right? It's like glued in there. So I don't actually need to measure that. So so shape one here is it's going to be 5 sides. Specifically, it's going to be the front plus the back. I'm putting F plus B, shorthand. You can do that. It's going to be left side plus right side. You could just use SS, side. And it's going to be the top. There is no bottom here. So this is another way of doing this. So before what we did was we doubled it. Now I'm just going to find it just how I'm just going to literally find it like this, the front and the back, for example, the left side and the right side. You could still times it by 2. It is dealer's preference. It's whatever you prefer, as long as you're keeping yourself organized. It's going to be so helpful that I have written this equation up here, and I'm going to leave myself just some space to fill this in later. I'm literally going to leave myself a little bit of space because I'm just going to plug what I'm going to find these sides. I'm going to plug them in there, and it's going to be perfect. So let's figure out the front and the back. Front and the back, what 2 numbers am I timesing together?
Is that 25?
This is 25. I know it's a little small. It's going to be 25 centimeters times, it's actually going to be 33 times 33 centimeters. So the front and the back are each going to be 25 times 33, 825 centimeters squared. And you can times that by 2 if you wanted. What I'm just gonna do up here is I'm just gonna say it's 825 plus 825. You could just times it by 2 if you want as well. Again, the organization is really, really important here. So I've done the front and the back. Now I need to do the left side and the right side, or the sides. Left side plus right side. Again, that's just how I prefer doing it. You might have a different way of doing that, and that's okay. So these red lines I'm just doing this to show what we're working on right now. So I need, make this a thicker line. I need these 2 lines here, right? What 2 numbers am I timesing together? It's going to be 25 and 27. Yeah. 25 centimeters times 27. What's that going to give me? 675. Squared. And then now I am not doing top and bottom. I'm just saying what's the top, because this shape here is combined with that other one, right? It has no bottom part of it. So the top part here is just going to be 33 times 27. Oh, 891 centimeters squared. Perfect. So I found that out, and I'm just going to substitute those numbers up here. So front and back, I'm done. Left side, right side was 675 and another 675. Again, if you doubled it, that's okay. You'd put like 1350 in there, I think. And the top I already established now is going to be 891. So all I need to do now is just add up all 5 of those numbers, and I should figure out the surface area of shape 1.
1,000.
I'm just going to make sure we have the same number. She said 4,000. Oh, did I goof up? I'm getting a different number. Let me just make the 825 plus 825 plus 675 plus 675 plus 891. 3,891. Did you add two? Did you add the maybe only one of the sides? If you use your up arrows, it'll actually it actually has a history on your calculator. I didn't figure that one out until this year.
Okay.
So I'm going to underline this or box it or circle it. I'm going to do something to it to show that that is an important number. Again, organization is huge. We're putting so much crap on our paper right now. It's going to be really hard to come back to it 10 minutes later. So I'm underlining to show that this is an important number. I need to use this later. Because this whole thing is shape 1 plus shape 2. So this is shapes 1 total surface area squared, centimeters squared. So now what I need to do is I need to find the area of shape 2. And now this little thing here creates a complication. This little thing here creates a complication. It's why we don't always times by 2. My top is not going to be the same size as my bottom, right? They are going to be different sizes because I'm not counting it. That's not a surface. It's inside it.
Oh, I see right there.
Yeah, and again, that's why it's really important for that because like you might have put 4,000, but I'd be like you just punch it on your calculator, you'd probably still get full marks for that. Yeah. So shape 2 has same thing. I always recommend write an equation for it. Shape 2 is going to be the front and the back, the left side and the right side. Plus the top, plus the bottom. I'm going to put BTM. You could put B as well, like that's fine, but so that's what shape 2 is going to be. Let me zoom in a little bit. I'm going to erase some stuff. We already have all our measurements. We've established this. So let's start going through it. So I'm going to do the front. Now, first off, are the front and the back, are they going to be the same for this shape? They should be. So I can actually combine it this time. You will not always think, I can't do this for the top and the bottom. I can't combine that. I need to calculate those both separately. But for the front and back, they'll be the same. So what's the width of it? So I have the width and the length.
So would it be 30 and 78?
Be 30 and 78, exactly. So 30 centimeters times, centimeters times 78 centimeters. So that should give you 2,340 centimeters squared. I'll put the squares in at the end. I want to keep my pencil that same thickness right now. But so 2,340 centimeters squared. So that's the front and the back. The next one I had was the left side and the right side. Now, are those going to be the same?
Left side, right side.
Yeah,
Probably.
they will be. Because remember, I'm only figuring out this part of the left side. Because I've already done shapes 1's left side, right? I'm not adding all of this up again. We don't want to add up the same surface area twice. So I can, in this case, it will be the same. It will be the left side and the right side. So what 2 numbers are my times in there? 27 and 30. Times 30 centimeters equals 810 centimeters. And then now I need to do my top, and specifically just the top, because the top and the bottom here, I can just tell just by looking at it, they're going to be different. So I'm only going to do the top part of shape 2, which is just this area I'm kind of highlighting here, right? It's just that. So what two numbers am I timesing together there? So there's going to be 45, and then this line right here is 27. Oh. 45, ooh, not plus, times 27, 1,215 centimeters squared. I will put the square in later. And finally, I just have the bottom. And what two numbers do I multiply for that one? Yep, 78 and 27. Oops, centimeters. That's 27 centimeters. Okay. Add all my little squares here. Okay. So like I said, this is why organization is important. I need to now go back up again. It's important to always remember like what we're trying to do, what are we trying to build towards? Because where you're probably gonna, like where this is gonna mess up a little bit is maybe you added something wrong, or you added something twice, or you forgot what number you were doing. It's really easy to slip up here. The math itself is not hard. You're taking two numbers and times them together. It's keeping organized. That's the hard part. So my front and my bottom are each 2,340. My left side and right side are each 810. My top is 1,000 or 1,215. My bottom was 2,106. And if I add all of those up, one second. Please confirm you get this number, 9,621. Okay, perfect. And again, that is just the area of shape 2. A lot of people are going to forget our final step. What's the last thing I have to do here? Well, I circle my final answer, but I don't have a final answer. I want to find the surface area of all of this, right? Technically, yeah. So technically, it's just shape 1 plus shape 2, right? You don't need to write this down. You don't need to write that down. You could just put the numbers, 3,891 centimeters squared plus 9,621 centimeters squared. You'll get your final answer of 13,512 centimeters squared. And now I'm just going to circle that as my final answer. This is why the circle, the underline, stuff like that is important. There are so many freaking numbers on that screen, right? It's really, really important to keep organized. The second you become disorganized and try this, like this took us 10 minutes, right? If you do this disorganized, it will not end well in most cases. Even if you know how to do it, we're human, we make errors. Keep yourself organized and it will greatly reduce that. For like your tests and stuff like that, show your work as complete as you can, because if you maybe just added something in wrong, like you got, like I saw you know how to do it, you just forgot to press the 1 or something, you'll probably still get full marks for it. It's so showing the work's important specifically for the concept checks, but also just in general. Is there any questions at all about this one here? Cool. Hearing none. We're going to skip question 7 for now. We'll come back to this one tomorrow. This is the same way. It's just one thing I will say, it's painting the walls and ceilings of a living room. It's just excluding the windows. So it's a 3D shape, but now we have to take away the windows part of it, and the doors and stuff like that. We'll deal with that one tomorrow. So I'll give you guys some time to practice here. Do not worry. Well, you can try question 5. If you're not sure, that's fine. You can try this. Again, I'm not going to like test you guys on the names of it. That's okay. It's just helpful to have the vocabulary. So don't worry too much about question 5. We should be able to, at this point, to do every question here. We should be able to do every question here, actually. Maybe not 11. That one might be a little bit mean, but you should have the tools to try all of these things here. So give this a shot. Please ask for help if you're not sure. It is really important we get this down.